Okay, guys, let's wait for 2-3 minutes so that everybody can join. And we are about to start our last BRB online session. Let's wait for everybody to join. So, okay, guys. So, welcome to our very special partner, Polygon. So, this is our last BRB online session. Dear builders and partners, I am Diksha, community advocate at Push Protocol. It's a pleasure to welcome you all. I extend a warm and heartily welcome to our BRB special partner, Polygon. Phase one of submission is over for BRB, but we are continue to accept more submissions. So be prepared. And you know that this submission is not basically very normal. It is bounty. So be prepared with good submissions, and we are accepting them. There is no hard line till now. So submit your submissions also as soon as possible. Okay, so basically, you know what BRB is. BRB is Billion Reasons to Build. It is an initiative by Push Protocol in collaboration with the best Web3 protocols in the space to solve some of the hardest problems of Web3 and win 5,000 plus each of them, also to grab a chance of 55,000 and bounty and exclusive swags more. So let's welcome our today's guest, Tony. Tony is DevRel lead at Polygon Labs. So we are having Tony. Hi, Tony. Let's
Hey,
begin with your introduction. The stage
hey,
is
hey.
all yours.
Thank you. Hi, everyone. Yeah, my name is Tony Orlando. I am the developer relations engineering lead at Polygon and also lead the developer education team. I'm really glad to be here.
Oh, that's wonderful. How are you doing, Tony?
I'm very well. How are you?
I am doing great. Are you planning to come with India?
I was planning to, but unfortunately, I've been on too many planes for this year, so I won't be able to make it this time. Yeah,
Okay, we are going to miss you. I hope we'll meet next time.
yeah.
So I think we are going to we are going to wonder like a very amazing workshop by you. So can
hmm
we start?
Yeah, sure. Let me just share my screen.
Oh, cool. Yeah.
Cool. Let me know when you're seeing that.
Yeah.
Okay, great. All right, cool. Well,
Yeah.
thank you, everyone. Today, I'm just here to talk to you briefly about the Polygon LXLY bridge, how it works, and uh, its various features, right? And this is just meant to give you just a general understanding of um, how everything is structured from a bridge standpoint, especially when you're talking about the zkEVM. So to get started, my name is Tony, DevRel engineer at Polygon, Tony Orlando on Twitter and on Telegram. So if you want to reach out to me with questions, please reply. Um, I take 7 business days because I have too many DMs, but eventually I will actually reply and get back to you. Um, so just to begin, Polygon zkEVM, it launched in on March 27th. A few million constraints for man. I think I forget the specific Vitalik tweet, but there was a corny statement he made at the beginning there that marked like the beginning of where we're going. And basically, the Polygon zkEVM launched, and it was launched with much fanfare. It was thought to be the holy grail, um, where zero knowledge could be paired with Ethereum to produce really strong scaling solutions. And when it launched, we then had like a perfect opportunity to begin looking at what it is. So, what is the Polygon zkEVM, you may ask? It's the next chapter of the Ethereum scaling because it allows Ethereum developers to deploy their smart contracts without making any changes, um, without making significant changes, and while also inheriting the security of Ethereum. So it's a very important piece of how we kind of build smart contracts because you still with the zkEVM you could deploy the exact same smart contracts onto a zkEVM rollup and have that function in a very strong way. Um, so the zkEVM could be looked at as a type 2 zkEVM, which means that there's some type 3 zkEVM currently, where there's some pre-compiles and certain opcodes that are still not supported. But hopefully inside of this quarter, we'll be able to have full EVM compatibility. That means all the way up to like type 1, type 2, meaning that there are no changes that you have to make. And with that, we'll have a very simple system for you to be able to deploy any EVM contract on the zkEVM and have that continue to function in a way that is predictable. But what is a rollup? So a rollup is comprised of, well, a zero knowledge rollup is comprised of one, zero knowledge technology, which are used to prove the validity of a statement without revealing that particular statement, and is to communicate state transitions in the context of blockchains and zkEVM solutions. And the thing to remember with this is that we don't really use a zero knowledge aspect of of zero knowledge, but we use its ability to be able to represent complex calculations as a summary that we could then make available on chain. And so it basically allows us to batch transactions and encrypt them in a way that makes it scalable, but also ensures that the whole um, the whole representation of the proof is cryptographically sound and is mathematically sound. And what is a rollup? A rollup is essentially a layer 2 scaling solution that increases throughput on Ethereum mainnet. And the whole point is that this could be an optimistic rollup or it could be a zero knowledge rollup, where the big difference being either they have fraud proofs on one side, or in the case of ZK rollups, is we have validity proofs. And so ZK rollups can process thousands of transactions in a batch and only post some minimal summary data to the Ethereum mainnet. And that's the whole promise of zk as you move forward. So how it works is essentially you have transactions are batched and processed. So if you see the penguins on the side there, those are just transactions waiting. And once they're batched, they are processed and put into like different like blocks. And those blocks um, are then submitted to the blockchain, where they're actually summarized, and a proof is generated representing all of the state transitions inside of that particular block. And that proof is then used to represent like all of those transactions, and that which is, yeah, that proof is sent to the layer one for in the data availability smart contract. Um, and so essentially, what the Polygon ZK EVM solution is basically allows us to reduce transaction costs and massively increase throughput, because we're able to take a whole group of different transactions, summarize them, and present a mathematically sound and cryptographic proof that represents all of those state transitions. So that's a real beauty of the Polygon zkEVM. So why Polygon zkEVM? You inherit the security of Ethereum. You have full EVM equivalence. It's fast and it's performant, and it gives you very low cost transactions. So it's a very good value proposition for different types of applications, say DeFi, or applications that need that level of security with uh, basically in using Ethereum. That gives you the greatest benefit. But then enter Polygon 2.0. So what happened when you realize, okay, so we have the zkEVM, it's now on mainnet. What more can we build with it? What more can we do with zero knowledge technology? Which is when Polygon came up with the whole notion of Polygon 2.0. And it's essentially a next stage of the evolution of the Polygon protocol. And it's our vision for unlimited scalability and unified liquidity, essentially. And part of the beauty of that is that by using zero knowledge technology, we could actually build a whole network of different blockchains that are interlinked, that work together, because they are sharing the same security infrastructure, and because they are secured by zero knowledge, then we could actually provide a single unified block space that people could use across different platforms. And we could also have unified liquidity, meaning that you could be able to move assets from one chain to another seamlessly. And what that essentially is kind of comprised of is that we have a proving layer, we have an execution layer, we have an interop layer, and we have a staking layer where the rewards for the protocol are being processed. And so the proving layer essentially represents the uh, the layer that basically generates all of the zero knowledge proofs for the particular protocol. The execution layer are the various chains that you see out on various platforms, and then you have the interop layer, which kind of facilitates the cross chain communication. and like ensures like the soundness across the entire protocol. And that's where we're going to start to jump off of inside of this talk, because people don't seem to understand it. But I'm going to go back to Mark Boyron Sweet. Mark is the CEO of Polygon, and he summarizes really, really well. So the Polygon of today that you know and love is comprised of the Polygon PoS chain and Polygon zkEVM. The Polygon of the future will be the PoS, the EVM chain, and the Maiden, and Polygon Maiden, which is our fast and secure privacy focused chain. And so let's imagine now we have those three chains. That's the Polygon of the future. And I think Polygon Maiden should be launching sometime Q1 or Q2 next year. But the end game, when we actually finish all of these things, is that we have those three chains, but also the ability for people to deploy all of those chains using the Polygon chain development kit, which is just like customizable zero knowledge secure chains that are easy to deploy, and you could deploy with a different gas token, different data availability. You could do a Validium, you could do a full roll up, you could make it centralized or decentralized. You have all those options inside of the CDK to make that possible. And so I want us to imagine the days where um, uh, when you needed to have a server, you had to have a co-location center, you had to buy hardware, you had to do all those things. That's what running a roll up has felt like right now, up until this point. But with the advent of like the Polygon CDK, it'll be as simple as provisioning a server on AWS. And so the Polygon CDK enables you to provision your own blockchain, in a way that gives you maximum customization and configurability, all the while secured by zero knowledge technology. That makes it a really compelling service offering. And so when we look at even like the future, we see all of these connected using the LXLY bridge. And the LXLY bridge facilitates transactions across the entire ecosystem. And we have the movement now from Matic to Pole, and Pole is our ecosystem token that's used to secure multiple chains, and will eventually facilitate decentralized sequencers, and also data availability committee for the validiums that will be running, specifically starting with the zkPoS, which is moving towards being a Validium. So this is just a basic rundown of where Polygon is headed. And visually, if you look at it, is that we are moving to a place where the app chains are anybody being able to deploy an app chain of their choice, maximum configurability via the Polygon zkEVM, I mean Polygon CDK. Then we also have Polygon Maiden, we have zkEVM that we know and love, and we eventually gonna have zkPoS, proof of stake, the one that we know as being deployed as a Validium, and all of them will be connecting to the LXLY bridge through an L1 contract. And so each of them have like different connections, and like the future of this protocol is that right now this image, you see everything, every chain essentially connecting to the LXLY contract on the Ethereum mainnet, but they'll also be able to communicate with each other. And so all of these app chains will have the ability to be able to communicate each other using the LXLY um, bridge. And I think if I've done any justice so far, is that I hope I've made it abundantly clear that the future of a lot of this relies on the ability to understand what the LXLY bridge does, because that is what is going to facilitate the cross-chain communication across the interop layer. So what is a bridge? A bridge is essentially inside of the blockchain context. It connects two blockchains, facilitating secure and verifiable communication between those blockchains through the transfer of information and assets. And so, information are basically messaging is like the core primitive that is available inside of the bridge. But we also have like different tokens that could be bridged as well. And you have wrap tokens, and you have native tokens, and so on and so forth. And various levels of like complexity built around the bridge. But yeah, this is how the bridge is actually. This is what the bridge actually facilitates. Um, but then there are types of bridges, right? So you have trusted bridges, which depend upon a centralized entity for their operations. They have certain trust assumptions concerning funding and like liquidity, and you have to like mostly rely on the users, uh, 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 on the bridge operator's reputation. So if you think of examples of this are like uh, Axela or Layer Zero or CCIP or any other type of bridge, third party bridge is absolutely vital and important for the security of the ecosystem. And I think in the end, we'll see a lot more support for a lot more projects prefer using a third party bridge just to be able to simplify all of the trust assumptions. But essentially, yeah, this is what it looks like. So you have bridges that depend upon a centralized entity. Trusted bridges specifically, you're essentially making a lot of trust assumptions, and you're saying, I trust that layer zero is going to bridge my assets from one chain to another. So you surrender the control of your assets to that bridge contract, and you let that go, and you trust that layer zero will be able to honor the transaction. But trustless bridges operate using decentralized systems, and um, basically they're built using the same security as the underlying blockchain. So each and every blockchain you see would have its own implementation of a bridge every layer two, and usually even alt L1s have a form of a bridge from their network to the L1. And what that facilitates is that there's a minimization of trust, because if you trust the network, then you essentially trust the bridge. Like if you trusted me to build it's basically kind of like somebody buying a whole car, and then you're able to get a spare part from the same company. This is something that you actually trust, as opposed to getting a third party uh, um, to actually provide you the same spare part. It could be the exact same spec, but the trust assumptions are very different. And so what they do is that a user then would surrender control to that particular protocol, and you have the ability to be able to move transactions between, I mean, to move your assets or send information between both networks in a way that doesn't depend on anybody. So this provides you a great deal of flexibility as a user. Um, so yeah, I hope we're clear on like the difference between trusted bridges and trustless bridges. So let's talk about the LXLY, and this will bring me to the end of my talk here today. What does the bridging process look like? So you deposit tokens on the L1. Afterwards, it appends an exit leaf and updates the global exit route, allows you to sync on L2. You claim the asset, and then you validate, and then the bridge essentially validates and completes the bridging process and makes those available. So basically, confirms that you actually did withdraw said tokens or you did claim your message. So that's, in a nutshell, that's how the LXLY bridge works. But let's look at it a bit more um, uh, concretely. The user initiates a transaction on Ethereum L1, and you deposit tokens to the Polygon zkEVM bridge contract. And that essentially triggers the bridge asset function of the Polygon zkEVM bridge contract. So if you're on L1, you would send money to the Polygon zkEVM bridge, and then a deposit is then created, and like a leaf is essentially created. So the bridge asset function calls the deposit function, and the deposit function calculates a leaf value based on your user's deposit details and adds it to the Merkle tree of the pending deposits. And so uh, the as the Merkle tree is structured, we just add an extra leaf that represents your particular transaction, and we're waiting for the sequencer to come and pick it up and push it to the L2. And a certain period of time, it could be 30, 40 minutes or something of that sort. The global exit route is updated on the L2 because the sequencer fetches the latest global exit route that was pushed from the L1 in its designated storage slot. And so once it realizes, oh, there's a new global exit route, it then goes in there, it picks that up, and then once the sequencer finishes processing that transaction, the asset is then available for the user to be able to claim. And the user could now construct a Merkle proof for their deposit leaf, for that specific leaf, or on the L2, and submit a transaction on L2 to call the claim asset function. And so once you call that claim asset function, you provide certain parameters that help identify that specific route and your specific deposit, um, including like the index and the proof and all those kinds of things, which will show you how to generate that. And then inside the claim asset function, what happens at the back end is that the claim asset function of the zkEVM bridge contract verifies the provider local proof and ensures the deposit leaves authenticity. And that's about it. Fairly simple, straightforward process. And this process could take some time, so it's important that people understand just how technical it might be. For a good example on this, give you time to scan this, but you should scan this and you'll get access to our ping pong code example. And what the ping pong code example basically goes through is how to actually set up the Polygon zkEVM bridge, get all the assets, so on and so forth, and like move that along. Um, and this is the official documentation for the Polygon Wiki, which is available there. Oh, sorry, excuse me. It's been a very long morning. But yeah, that's essentially it. That brings me to the end of my talk here. Unless anybody has any further questions, I'm just going to go back to the ping pong code example QR code so everybody could scan it one at a time.
Okay, that's actually very great. You can exit like okay, screen. Okay. So I really like the slides also, personally, Tony, because there are like memes and I'm liking them while listening to you also. I like the way
Mm.
you present the whole idea and scenario of the bridges. So yeah, so I think this is the last BRB online we are having. So if there are any doubts or anything, you can post in the chat, and Tony is here to help you guys, or you can message him, text him over Twitter. He's always there. Also, we are always there on Discord, hanging around for your doubts, for helping you out in your things. So we can also move it there. So we are accepting the submissions. You're still having a chance to have a fully sponsored ETH India trip and good bounties and good money. So guys, please buckle up and be ready with your favorite, like most amazed submission till now. So yeah, show activeness in the sessions. So this is all from my side. Tony, this is just personal in my mind. Like there is Polygon is having the Polygon Connect, right? S-
Hmm.
Yeah. So can you just explain the like idea or scenario behind like what we are going to do in the Polygon Connect? What are the new scenarios we are dealing with? So yeah.
Oh, this connect is going to be an amazing, amazing experience. So we have about 4 different tracks, 4 different events. So you have a builder stage, you have a technical stage, you have a dev stage, and I forget the last one. Oh, so sorry, the main stage, of course. And you have different talks and different tracks happening. It's probably like it's the biggest part of FOMO I have about not being able to actually come because of the it'll be a very action-packed day. So we have different layer twos coming. We have different investors who will also be there. Different builders. A very very technical workshop where we'll be going into the weeds of zero knowledge proofs and so on and so forth. It's like an amazing experience. And I do also want to shout out ZK Bankai, which is a an event that we're running um, as well. Let me just pull up the specific date so I don't get it wrong.
Oh, this is a very
Um,
great idea. Yeah.
so ZK Bankai is actually on the first. Uh, it's actually today. So yeah. Sorry, I think I was a bit late in promoting
Yeah,
this.
quite late.
No,
It's
it
okay.
starts today. It ends on the 7th.
Oh,
And it's like a hacker house for it's like a hacker house for developers interested in ZK Bankai. or zk generative. So this is the
Okay.
Twitter for it. Um,
That's great. So yeah.
yeah.
So I think
So very action-packed week. Um,
okay.
there's various things there that you would absolutely enjoy.
Oh, that
So let me just pull that up.
Push community is also looking forward for every events and for with Polygon also with every our push protocols partners. So yeah,
Yeah.
I think this is a time to say bye bye. Okay, you are about to okay,
Yeah.
okay.
So no, just showing you ZK Bankai House. First to the seventh, you're gonna see a lot of different people building different things. So it'll be really, really good for people to go and check it
Ah, I
out and
have
see.
checked this in your Twitter profile. Yeah, I gone through it.
Yeah.
You posted it. Yeah, yeah, that's so great. And I think every mm, blockchain or Web3 enthusiasm is looking forward to it. Also, Push is looking forward to it to know new ideas, to always innovate, to always create. So yeah, I think this is a time to say bye to you. It was just a very amazing session with you, Tony. And it's a FOMO for me because now this is the last BRB session. I am ending with Polygon.
Um,
Yeah, and
this
I
is the best
think, yeah. So basically, thank you for being here, Tony. It's like very grateful to you. So yeah, thank you guys for joining. Also, excitement doesn't end here because there is ETH India Global coming around. Also, we are having BRB Bangalore. So do join, guys. Thank you, everyone. Thank you, Tony. Thank you,
Bye.
Polygon. Bye.
See you.
Have a good day. Bye. See ya.